Is highly available enterprise Redis. My name is Vishaka Gupta, and I am the marketing coordinator at Redis Labs. I'm just going to give you a brief overview of what you're going to learn in this webinar, and then I'm going to pass it on to our presenter, who is Itai Raz, and he's the VP of Product Management at Redis Labs. So to start off, you're going to receive a brief presentation given by Itai in which he will explain how to scale, monitor, and manage Redis deployments, as well as how to make Redis highly available with cross-data center, region, cloud, auto failover, and disaster recovery. Then you're going to get to see a live demo of the Redis Labs Enterprise Cluster, RLEC. And at the end, we're going to have a Q&A session. However, you don't need to wait till the end to ask your questions. On the toolbar for GoToMeeting, you're going to have a questions tab. And you can go ahead and type in your question at any time during the presentation. And what I will do is I will assign it to Itai, and at the end, we will take those questions. And we're going to try to go ahead and answer all of your questions in this webinar. But in case we're not able to answer it, you can go ahead and email Itai at redislabs.com, or you can tweet to us at Redis Labs, and we will make sure to get you an answer to your question. So I'm going to go ahead at this time and pass the mic to Itai.
Hello, everyone. Can you hear me? Fish, can you hear me?
I can hear you. You're crystal clear.
Okay. So thanks, everyone, for joining our webinar. As Vish mentioned, my name is Itai Raz, and I'm VP of Product Management for Redis Labs. So let's go ahead with the presentation. So what we'll cover in the webinar today is I'll give you an overview of what is Redis Labs Enterprise Cluster, or as we call it, RLEC. I'm going to explain how RLEC helps solve some of the difficulties of managing Redis. And the main part of the webinar is going to be a live demo where I'm going to show you the UI of RLEC. I'm going to show you how to create a database. I'm going to show you how to scale a database. I'm going to show you different failover scenarios as well. Things that we're not going to cover in the webinar, first of all, is what is Redis. If you want to learn about Redis itself, then you should certainly go to the Redis.io website. And there's also a great book written by Dr. Josiah Carlson called Redis in Action. And you can get a free copy of it or read it online on our website. And I've put the link on this slide, which you'll be able to see afterwards. I'm not going to cover how to install or set up RLEC. If you want to learn how to do that, then there's the online documentation that we have on our website. And there's a blog post series that I've written that covers all the basics with step-by-step directions on how to do that. So you can certainly learn that there as well. And I'm not going to talk about how to achieve over 1 million ops per second with sub-millisecond latency. If you want to learn about that, then you can watch a previous webinar that was presented by my colleague Itamar Haber, and there's a link to that webinar here. And the next blog post in the series, I'm actually going to explain how you can configure RLEC in order to achieve that. Okay, so at a very high level, what is RLEC? What is Redis Labs Enterprise Cluster? So it enables you to install an enterprise-grade cluster that acts as a container for managing and running multiple Redis databases in a highly available and scalable manner with predictable and stable top performance. And let's go ahead and talk, have only 4 slides, that's it, and the rest of the demo. Let's talk about all these kind of major bullet points. So we'll talk about the scalability features of RLEC, high availability features, performance, and what it means that it's enterprise grade. So from a scalability perspective, first of all, RLEC extends Redis to multi-core and multi-node clusters. And enables you to get real-time automated scaling. You can reshard, you can rebalance, you can do cross-shard operations, and you can do all of those with no downtime or overhead while you're scaling your database or the cluster as a whole. So bottom line, what does this mean? So for the database, first of all, you can run multiple Redis instances in a single node or in the cluster, which is a group of multiple nodes. You can cluster or shard Redis to take advantage of the multi-cores on a single machine. and scale the database that way. And then you can cluster or shard Redis across multiple servers, and by that you can break the limitation of a single node or a single machine, or if you have a very high load, then you can balance the load across multiple machines or nodes. And then, like I said earlier, you can resize, you can reshard, you can rebalance, you can migrate shards across the nodes, and all of that without any downtime at all. And we'll see some of that in the demo later. And then for the cluster as a whole, you can scale the cluster by adding additional nodes and then rebalancing the shards across the different nodes. So that is a high level, the scalability features of RLEC. Then if we talk about high availability, so first of all, you get fully automated high availability. So the cluster knows to identify when there is a need to do failovers, and we'll see that in the demo as well. It supports cross-cloud data center region or zone replication and auto failover for those. And from a high availability perspective, except for replication, it also has persistence, disaster recovery, and backup features. So bottom line, what this means, so first of all, replication. To achieve high availability, you can keep a slave copy of the data. And if there's any issue with the master copy of the data, then you can the cluster will automatically fail over to the slave copy, so you don't lose availability. And we have a unique technology to achieve that with only one replica of the data. So you can get significant cost savings through that. From a failover perspective, then of course it's automated, and the cluster knows when a failover is needed, but you can also do manual failover if you need, and I'll show that as well in the demo. There is a rack or zone awareness feature in RLEC, which means that you can map the nodes to a physical rack or to a logical zone, and then if you enable replication, then the cluster makes sure that the master copy and the slave copy of the data reside on different racks or zones, and by that you achieve high availability or better high availability. From a persistence perspective, then you can the cluster knows how to persist data to the disk, and you can recover the data from the disk afterwards. And it supports both a snapshot, so you can take a snapshot of the data every certain period of time, or you can use the append-only file or AOF, which means that the cluster collects every 1 second all the changes that you've made to the database, and then you can run those commands afterwards to recover the data. And then you can configure periodic automated backup every certain periods of time. You can export the data at any point that you want, and then of course you can import data from files back into the database. So that is high level about high availability features. If we talk about performance, then the cluster makes sure that you get top performance achieved under any load or cluster size. We talked earlier about this scaling feature where you can shard or cluster the database across multiple shards, and by that use multiple cores. So by that you can achieve performance, and we'll see that actually in the demo. And there's different built-in performance enhancement techniques. So bottom line, first of all, the cluster uses a shared nothing architecture, which maximizes the performance of each database and protects the database from the nosy neighbor scenarios. There's auto migration logic within the cluster to isolate high-load databases from other databases that might interfere with them. There's various file system level improvements. So first of all, we talked earlier about the AOF mechanism, the append-only file. So there's various optimizations. For instance, when you enable AOF, then usually it's done from the master copy of the data, and it might hurt the performance. So we have improvements where if you enable replication for the database, then the AOF will be done from the slave copy and will not interfere with the performance of the database in any way. There's different improvements that we made to the AOF rewrite mechanism. There's optimal access to storage in the implementation, and we support burst write operations as well. And then last but not least, RLEC includes a zero latency proxy that does different runtime optimizations to include performance. So for instance, it can decide to do just-in-time pipelining even if the client did not request that. It uses socket connections and connections pooling and multiplexing, all to ensure top performance. And then the last point that we talk about is the cluster being enterprise grade. So first of all, you get a very rich UI, which we'll see in the demo. You get a command line interface for advanced administration called RLEC-Highly, which we'll see in the demo as well. And then you also have a REST API that you can use to automate all the actions in the cluster. And you also get monitoring, so we'll see in the demo the different dashboards that you can see in order to monitor and understand exactly what's going on in the cluster. And there's also alerting built in, so you can get alerts in the UI itself or by email. It's a proven technology that's supporting thousands of customers all around the world, and we also provide 24/7 support and Redis expertise if you need it. So bottom line, you get full cluster and database management through an easy-to-use UI, which we'll immediately see. You get the command line interface, RLEC-Highly, and the REST API-based management if you want to use those. You have multiple graphs and dashboards for the database, for the shards of the database, for the nodes in the cluster and the cluster as a whole, and we'll see all of these now. And you can also get email alerts for the database, the node, the cluster, and different events that happen within the cluster. And you can also integrate it with external monitoring tools such as Nagios. So that is it from kind of more of the slides content. Now let's talk about the demo that we're going to see. So the demo that I'm going to run is all running on Amazon Web Services on AWS. I have 4 instances running on AWS. 3 of them act as RLEC nodes, so I've went ahead and installed the RLEC software on those 3 instances. I created a cluster from them and joined all the nodes together, so they all act together as an RLEC cluster that has 3 nodes. And then the 4th machine is going to act as the client, which we'll use to run commands against the database. So that is kind of the high-level architecture of the demo that you're going to see. So let's go ahead and see the demo itself. So what I'm going to show you first, this is the AWS Management Console, and you can see what I just described in the slide as the architecture of the demo. So you see that we have 3 nodes here. These are the instances that I've installed the RLEC software on it, and I created the cluster and joined all of them to act as one cluster. And then this is the client machine that I'm going to use in order to run the commands on them. Next, what I'm going to show you is the RLEC UI itself. So this is how it looks. You see it's a web interface. And let's do a quick tour. So I'll show you all the different screens that you have in the system. So first of all, the cluster section. You can see we have this type of dashboard here, and you'll see that this basic structure repeats itself in different pages in the system. So let's quickly go over it. You can see at the top, you can decide to watch different periods of time, say the last minute, the last 5 minutes, all up to the last year to see the information in the dashboard. You can see at the top here that we're looking now at the cluster as a whole and on node 1 in the cluster. And we're looking at the CPU usage at the moment. So these 2 graphs are kind of used in order to look more deeply into certain metrics. And you can see at the bottom, you get the minimum, average, max, and last value. And then at the bottom here, you see there's a section for the resources. Here you can have, you see the cluster as a whole and each of the nodes in the cluster, and you can choose which resources you want to view at the top 2 graphs. So I can choose to see a node 1 on the right here and node 2 on the left, for instance. And then at the bottom, you see a set of metrics that are relevant to all these resources. So you can choose which one you want to further inspect and choose to kind of move them up and inspect them in the big graphs. So you see different types of metrics that are relevant for a node and the cluster as a whole. Then there's the configuration section of the cluster, so you can see how long it's been up. You can see the software, the RLEC software version it supports, the Redis version it supports, the memcache. It has the rec zone awareness enabled. You can see the number of shards it has and the limit. And then you can see the available and used ROM, persistent storage, and ephemeral storage. So that is what you can see at the cluster level. If we look at the nodes, then once again, you can see the three nodes that we talked about earlier. For each node, there's some high-level information you can see here, like the IP, the zone it is mapped to, how many shards it has on it, the available and used memory, persistent storage, the CPU usage and network, and the status, of course. And you see we have a rebalance button here. So if you get to a state where the cluster is not balanced, you can click here and it will automatically start balancing the cluster to make sure that you get top performance. If I click now on one of the nodes and go into the nodes page, then you see it has a similar structure to what we've seen earlier. You see here you have an option where you can remove a node from the cluster, or you can take a node offline if you need to do some maintenance on it. As we saw before, there's two graphs at the top here they can use to inspect certain metrics, and then you have the metrics here that are relevant to a node that you can choose which ones you want to move here to the top and see those in the top graphs. From a configuration perspective of a node, once again, you can see the uptime of this specific node, the software versions that it supports, the IP, or it might have multiple IPs that it has, the zone or rack that it's mapped to, the OS version, and the hardware architecture, and then once again, the available and used RAM, persistent storage, and ephemeral storage on this specific node. I'm going to go over the databases afterwards when we do the demo itself, so I'll just show the settings sections here. You can see there's general settings here. So for instance, if you want to sign up to get email alerts, you would configure the email server settings here, and then the cluster will use these settings in order to send emails. You can define the team members here, but what's interesting is the alerts. So you see there's a set of alerts here related to the cluster and the cluster nodes that you can sign up for. These will show up in the UI itself, and then if you configure the email server settings and click this checkbox to receive email alerts, then you'll also receive all these alerts by email. And you see there's different events here that you can sign up for alerts on, and different alerts that you can define thresholds for. So for instance, if persistent storage has reached 70% of its capacity, an alert will be raised in this scenario. So this is related to alerts at the cluster and node level. And then last, there is a system log here where you can see all the different actions that were taken in the system. So let's go to the interesting portion here of the databases. So here you can see a view of all the databases that are currently in the cluster. And you can see there's one here that I prepared for the failover demo. And let's go ahead and create a new database here. So I click Add. You can choose whether you want to create a Redis database or a memcache database. I'm going to choose Redis. You need to give it a name. So I'll give it a scale demo as the name. You need to decide the size of the database or the memory limit for it. So I'm going to choose 10 gigs. You can choose to enable replication. Remember I talked earlier about the high availability feature, which means that you keep a slave copy of the data for your data set. So if you enable that, that's what it would do. And you can choose whether or not you want to use the rec zone awareness feature. So I'm not going to enable the replication for now. From a data persistence perspective, then as we talked earlier, you can do a snapshot at either every 1 hour, 6 hours, or 12 hours, and the system would automatically take a snapshot of all your data. Or you can use the append-only file, which means that every 1 second it will collect the changes that have been made to the database. And then you can assign a password if you want to secure access to the database. So I can click Activate now and the database will be created, but I want to go over and show you the more advanced options in here. So you can assign a specific endpoint port number, which I'm going to do now. So I'm going to give it the port 10,001. You can enable database clustering, which means that you will shard the database into multiple shards. And you can see you can choose how many shards you want to shard it into. And you can choose whether you want to use the standard hashing policy or you can define a custom hashing policy which will enable you to define a set of regular expression rules which the cluster will use in runtime to decide where each piece of data should go, so which shards it should go into. I'm not going to enable the clustering at the moment. From a data eviction policy, then it supports all the Redis eviction policies. You just need to choose the one you want to use. The replica feature is a very interesting feature where you can define this database to be a replica of one or more other databases. And then once you do that, this database will keep syncing all the data from the other sources that you defined. This could be very useful, for instance, if you have a lot of read load, then you can define one database that you'll do only writes into, and then define multiple replicas for it, and then do the reads from all the replicas, and then you're kind of distributing the load between writes and then between the reads across multiple databases. Or let's say you have a Redis database external to the cluster and you want to move it into the cluster, then you can sync all the information from the external database, and once the sync is done, you can turn off the replica feature, for instance. I mentioned earlier you can do periodic backups, so you can choose to backup for the cluster to automatically back up the database every 4, 12, or 24 hours. You can choose different locations. These are the 3 that we currently support, and we're adding more in here. And then alerts at the database level. So you see you have a set of alerts here. For instance, if the data set has reached a certain threshold, or throughput is higher or lower than a certain threshold, latency is higher than a certain threshold, or the periodic backup has been delayed. So you can enable these alerts and both get them in the UI itself and also receive email alerts for them. So I'm going to create the database now. So the database has been created and it's active. You see once you've created a database, you can choose to import a data set in it or to export the existing data set. You can delete or edit the database. And you see that now we have the endpoint here that you can use to connect to the database. So let's go ahead and do that. So here I have a SSH session into the client machine that I showed you earlier. And what I'm going to do now is run a command to start having some activity on this database. So what I'm using here is a tool called memtier benchmark, which is an open source tool that we developed, and you can get it on GitHub, or if you install RLEC on a machine, then it's installed with it and you can use it. So I'm going to use it now. It connects to the database and start running reads and writes on the database. And before we go ahead and look at the metrics and the dashboard for the database itself, there's also a slow log feature here. So if you have very long-running commands which are slow, then these get collected and you can see them and analyze in this screen. So let's look at the metrics dashboard of the database itself. So it's similar to what we saw earlier at the cluster and node level. And you can see that we're currently looking at the hops per second and the latency that this database has. And there's a bunch of metrics here that are relevant for a database that you can choose to view here or move up into the 2 big graphs. And you can see you have the hops per second and the latency we're currently looking at, but you can see the reads per second, writes per second, other commands per second, latencies for reads and writes and other commands, the used memory, total number of keys, the hit ratio, the number of connections, and so on. So a lot of interesting information that you might want to view and analyze the database for. So now we're looking at the database level itself. There's also a shards view. So let's see how that looks. So currently the database is not clustered, so it has only one shard, and it doesn't have replication enabled, so it doesn't have a slave copy. So there's not a lot of interesting information to see here. You can see a view of the database as a whole, and the one shard, master shard that it has that you can see is on node 3. And then there's a bunch of metrics here that you can choose to view per shard. Let's go back to the database dashboard itself. And what you can see is that we're currently running, so the benchmark that I'm running is achieving somewhere around close to 1 million ops per second with a latency of a little over 3 milliseconds. And you can see the average here. So close to 1 million ops per second and 3.23 milliseconds. So this is not good enough performance for what I want. I want to achieve higher ops per second and lower latency. So how do I scale this database? So what I can do is go ahead and enable clustering and shard the database. And let's go ahead and do that. So I'm going to go into the configuration view and click Edit. You see there's different parameters here that you can configure. If you need to increase the size of the database or decrease it, then you can do that as well. You can enable the replication and so on. But what I wanted to do now is to enable database clustering in order to shard the database. So I'm going to shard it into 2 shards. I'm going to keep the standard hashing policy. And I'm going to click Update. Might take a few seconds for this to happen, but what I want to show you is that the client is still running. You see there's maybe a slight decrease here in the ops per second that it's achieving in these numbers here, but basically we didn't get any disconnect. Everything is still working fine. And now you see that it's starting to go up again, the ops per second here. So let's wait. Now it finished the changes, and let's go back into the metrics dashboard and see what's happening. So before, if you remember, we were close to 1 million ops per second with over 3 milliseconds latency. And now that we sharded the database into 2 shards and we're kind of, the load is split across 2 shards, you see that the ops per second went up to over 1.5 million ops per second, and the latency went down from over 3 to a little over 1 millisecond. So pretty easily, without losing any connectivity to the database, I was able to scale it and achieve higher ops per second and lower latency. So I'm sure you're all clapping right now, but I can't hear the applause, but agree with me that it's a great way to scale your database. If we go ahead and look at the shards view now, then now that we sharded the database into 2 shards, then you'll be able to see that we have 2 master shards now. Before we had only 1. And you see that the first master shard is mapped to the hash slot between 1 and 2048, and it's on node 3, as it was before. And then the second master shard is mapped to hash slot 2049 to 4096, and it's on node 2. So we have some more interesting information here. Now the next thing I want to show you is how you achieve high availability, because at the moment I only have 2 master shards, and if anything happens to one of these master shards, then the data will get lost and I lose my data. So in order to do that, I need to go ahead and enable replication. So I'm going to edit the database again, and all I need to do is go into the replication checkbox, click it. I'm going to keep direct zone awareness, which makes sure that the slave copy of the data will be placed on a different record zone. And I'm going to update the database. Takes a couple of seconds, and it's done. And if we go back now into the metrics and go into the shards view, then before we only had 2 master shards. Now what you can see is that we have the same 2 master shards, but we also have, you can see here that it says slave and slave. So we have a slave per master shard. You can see that it's mapped to the same hash lot as its master, and this one is also mapped to the same hash lot as its master. And it's, of course, on a different node than the master shard. So in case there's any issue with the master copy of the data, the system will automatically fail over to the slave, promote it to be the new master, and you won't lose any data, and you shouldn't lose any connectivity. So this is how we enabled high availability for the database. So that's it for this part of the demo. What I want to show you next is failover scenarios. So let me just go ahead and delete this database. Okay, so this second portion with the failover is a little complicated to kind of manage, so I pre-recorded it earlier, and I'm going to play the video now, and I'm going to explain to you exactly what's going to happen here. So let me start running it. So, okay, so you see we have the failover demo that I just showed you. We'll go into it, and you see that from a configuration perspective, this is the endpoint that you can use in order to connect to it, and you see it uses port 10,000. The memory that it is 10 gigabytes. It has replication enabled, which means that it has both a master and slave shard at the moment. It's not sharded, so it has only one shard. And you can see that the master shard is on node 1, and the slave shard is on node 2. Now what I want to show you, I talked earlier about the fact that we have a command line interface called RLEC-Highly that you can use in order to do more advanced management actions. So let's go ahead and open that. So I'm connected now to one of the nodes, and I'm going to activate the RLEC-Highly tool. So you see RLEC-Highly, and now I'm in it. And the RLEC-Highly tool has a status command which enables you to see the configuration of the cluster. So you can see that the cluster has 3 nodes, as we saw earlier. You can see different information on the nodes. You can see that node 1 and node 2 have each one shard on it, which is what we saw in the UI. The master shard was on node 1, and the slave shard was on node 2, so we can see that in here. So that's from a cluster and nodes perspective. You can also see the databases. So we have the failover demo database. You can see it has only one shard, but it has a replication enabled, which means that it has a slave shard as well, and that's the endpoint that we saw in the UI. And then you can see the different shards that are in the cluster at the bottom here. So you can see there's a master shard on node 1, as we saw in the UI, and a slave shard on node 2, as we saw in the UI as well. And then there's the endpoints up here. So each database has an endpoint that you use to connect to it. And then if you enable replication for high availability, then you have both a master and a slave endpoint as well. So in case there's any issue with the master endpoint, you can always fail over to the slave endpoint. So you can see that the master endpoint is on node 3 at the moment, and the slave endpoint is on node 1. So what I want to show you now is how the failover works. In order to do that, I'm going to run from the client. I'm going to use a Python script. What it does, it continuously pings the database. It identifies whenever there's a disconnect, and then it measures the time until it's able to connect again. So it actually measures how much time a failover takes. So I'm going to run that script. If you look here at the right, and when we do the failovers, you'll be able to see the disconnections and how much time the reconnect takes to measure how much a failover takes. And now that we're running this script, you see that there's some traffic going on the database because it's continuously pinging the endpoint. So this is what we see now in the UI here. So we go back to the RLEC-Highly tool, and we're going to run the failover command here to failover the endpoint first. So you use failover database, you give the database name. I'm saying that I'm going to failover an endpoint, and I need to give the endpoint ID. So you can see that the master endpoint is a node 3 and has an ID of 3. So I need to give the number 3 here. Now pay attention. When I'm clicking here, enter, and the failover is happening, you'll see on the right here that there was a disconnect, and then it was able to reconnect back again after 0.06 seconds. So in a fraction of a second, the cluster was able to fail over the endpoint from the master endpoint to the slave endpoint very, very quick. And remember that the master endpoint was on node 3 and the slave endpoint was on node 1. If we run the status command again, we'll be able to see that the failover actually took place. So we'll run the status command again and look at the endpoints. And you're able to see now that the master endpoint is now the one that was on node 1, and the one that was master before was demoted to be a slave. So in case there's any issue with the endpoint, any issue with the node that the endpoint is on, you see how quickly the cluster is able to do a failover. Now we're going to do something similar, but we're going to fail over shards. So you see that the master shard is currently on node 1 and has the ID 6 here at the bottom. And then the slave shard is on node 2. So we're once again going to run the failover command, but now we're going to do it on a shard, and we need to give the ID of the master shard, which is 6. If you take a look at the right, you'll be able to see that the Python script will see that there's a disconnect again, and when it's able to connect again, you'll see how much time it took. So let's run the command. The failover is taking place. You saw that there was a disconnect, but then after 0.47, so less than half a second, it was able to reconnect again. So the failover between the master shard and the slave shard took less than half a second. So remember that the master shard was on node 1 and the slave was on node 3. And now if we run the status command again, then we'll be able to see that the failover actually took place. Oh, sorry, I was talking about the endpoints. So the master shard was on node 1 and had the ID 6, and the slave shard was on node 2 and had the ID 5. And now that we ran the failover and we ran the status command again, you see the failover actually happened, and now the master is on node 2. So next I'm going to do something much more extreme. You see that the master shard is currently on node 2. What I'm going to do now is actually completely shut down the machine that node 2 is running on and see how much time the failover happens when a whole node actually goes down. So let's go ahead and do that. So I'm going back into the AWS Management Console, and what I'm going to do is completely shut down the machine that's running node 2. So I'm going to click stop to completely stop the machine. And then if we look at the Python script again, you see that the database, of course, got disconnected. But then the cluster identifies that, and you can see that the client was able to reconnect after 7.64 seconds. So sometimes this takes 4 seconds or maybe less, sometimes 5 seconds. Here it took a little over 7 seconds, but the cluster was able to identify that the whole node got shut down and make sure that the failover happened, so the client will, so the database will be available again and the client will be able to connect to it. So let's see now what happened if we run the status command again. Then what you're able to see now is that node 2, the cluster has identified node 2 is completely down, it's not working. The master shard that we had earlier, Redis number 5 on node 2, was the master, now it's down, and there's an error, so it did the failover, and now the master is back to be Redis 6 on node 1. So this is why the database was available again, the client was able to reconnect to it. So it took a little over 7 seconds for the cluster to recover from a complete failure of one of its nodes, which is pretty quick. So what I'm going to do next is actually bring back online the machine that was running node 2, and you'll see that the cluster will be able to recognize that the node is back up and make it part of the cluster again. So I'm going to start the machine. And you see that it's still pending, so we'll have to wait a few seconds until the machine will be up. It's still pending. Refresh again. Still pending. And now we refresh again. And you see the machine is back up, so let's run the status command again in RLadmin. So you see that it still shows that if node 2 is still down and the shard is still down, so it hasn't recognized yet that the node is back up. So we wait a couple of seconds and run the status command again. Now you can see that it recognized that the node 2 is back up and it's okay, it's operative, but the shard is still down. So we need to wait a couple more seconds. and we run the status command again, and now you see everything is back in order. So the node is back in the cluster and it's okay. The shard is back up, and of course it's still the slave shard because we had the failover happen when the node went down, and everything is back in order and back in place. So we saw what happens when there's a complete failure of a node in the cluster. So that is it for the demo that I wanted to show you. Let's go back to the presentation itself. So what do we actually see in the demo? So first of all, I gave you an overview of the UI and the different pages and different screens, the different dashboards that you can see, and the different alerts that you can sign up for. I showed you how to create a database, which was pretty easy and simple. And then I showed you how you can scale the database through sharding it into 2 shards, and by that achieving higher throughput and lower latency. So we went up from less than 1 million ops per second to 1.5 million ops per second, and we went down from over 3 milliseconds latency to a little above 1 millisecond latency just by sharding the database into 2 shards, and we didn't lose any availability while doing so. Then I also showed you that I can enable replication on the database to ensure high availability. I showed you how quick an endpoint failover happens. It was 0.06 seconds. I showed you how quickly a shard failover happened, which took less than half a second. And then I showed you how the cluster can recover from a complete failure of a node by shutting down the machine. And we saw that that took a little over 7 seconds for the client to regain connectivity to the database. So that is it. I wanted a few words about Redis Labs, about our company. So we enable high performance, seamless scalability, and true high availability, reliability, and best-in-class expertise for Redis. We're the home of open source Redis and the commercial provider of enterprise class Redis, both on premises, which is the product that you saw, Redis Labs Enterprise Cluster, which you can, of course, install on premise, but you can install it on the cloud like I showed you on AWS. And we also provide an online service called Redis Cloud on all the different clouds. We have over 5,500 paying customers in over 40 countries. And in addition to that, over 34,000 trial customers. We manage over 115,000 database and provide 24/7 support for all of those. We are headquartered in Mountain View, California, and our R&D center is in Tel Aviv. And we provide best-in-class expertise for Redis. That's it for the presentation and the demo.
Very much for presenting, and everyone, thank you for joining the webinar. We appreciate it. And if you have any more questions, or if you think of any more questions, you can go ahead and either tweet to us at Redis Labs, or you can go ahead and email Itai directly, itai@redislabs.com, and he will do his best to get you an answer quickly. Also, I'm going to go ahead and send out an email to you guys, which you should receive on Monday, and it'll have the recording as well as the slides. So that's it. Thank you for joining, and we look forward to seeing you guys attend our next webinar.